Imagine you're living in 1997. The internet is still young. Most people have never heard the term artificial intelligence. Smartphones don't exist. Social media doesn't exist. And when people think about intelligent machines, they usually imagine science fiction movies. Now, imagine someone walks into a room and tells you that within your lifetime, machines will beat world champions, create art, write software, and even talk like humans. Most people would have laughed. Not because they hated technology, but because the idea sounded ridiculous. At the time, computers were useful tools. They could calculate numbers, store information, and follow instructions. But intelligence, creativity, human conversation, those seemed completely out of reach. And yet, something was about to happen that would force the world to take artificial intelligence seriously for the first time. A machine was preparing to challenge one of the smartest humans on Earth, and almost nobody believed it had a chance.
That human was Garry Kasparov. If you followed chess in the 1990s, you knew his name. Kasparov wasn't just a champion. Many people considered him one of the greatest chess players in history. He had spent years defeating elite opponents and dominating the game at the highest level. To many people, chess represented something special. It wasn't about strength or speed. It was about strategy, planning, creativity, the ability to think several moves ahead. In other words, it represented human intelligence, which is why the challenge sounded so absurd. Kasparov wasn't facing another grandmaster. He was facing a machine called Deep Blue, a supercomputer built by IBM. At first, many people weren't worried. Sure, computers were getting faster, but faster wasn't the same as smarter. Or at least, that's what people believed. Then, the match began. And very quickly, something felt different.
Move after move, Deep Blue kept responding with incredible precision. It didn't get nervous. It didn't get tired. It didn't feel pressure. And unlike human players, it could analyze enormous numbers of possibilities in seconds. At first, spectators expected Kasparov to expose the machine's weaknesses. After all, he was the world champion. But as the games continued, people started realizing this wasn't a publicity stunt. The machine was actually competing. Then came the moment nobody expected. Deep Blue defeated Garry Kasparov. For the first time in history, a reigning world chess champion had lost a match to a computer under standard tournament conditions. The headlines spread around the world. Some people were amazed, others were disturbed, and many began asking the same question. If a machine can defeat the best chess player on Earth, what else might it eventually be able to do? The answer would arrive sooner than anyone expected.
But after Deep Blue's victory, many people weren't worried. They had an explanation. Chess, they argued, was just calculation. A computer wasn't really thinking. It was simply processing more possibilities than a human ever could. According to this view, Deep Blue hadn't proven intelligence. It had only proven speed. And for a while, that explanation seemed reasonable. Then, researchers turned their attention to another game. A game that many experts believed would remain impossible for machines for decades. The game was called Go. At first glance, Go looks simple. The rules can be learned in minutes, but mastering it is another story entirely. In fact, many researchers considered Go far more difficult than chess, which is why what happened next shocked the world.
Unlike chess, Go contains an almost unimaginable number of possible moves. The number of potential board positions is so enormous that traditional computer approaches struggled badly. For years, experts believed AI would need decades to catch up. Some thought it might take 10 years. Others believed it could take much longer. Then DeepMind introduced AlphaGo, an AI system designed specifically to tackle this challenge. In 2016, AlphaGo faced one of the strongest players in the world, Lee Sedol. Millions watched. Most expected the human player to win. After all, this wasn't chess anymore. This was the challenge experts thought machines weren't ready for. But the match was about to produce one of the most famous moments in AI history. During the second game, AlphaGo made a move that confused everyone. Move 37. Commentators stared at the screen. Professional players watching the match were stunned. Some believed the AI had made a mistake. The move seemed strange, unnatural, even wrong. But as the game continued, something became clear. The move wasn't a mistake at all. It was brilliant. What looked impossible from a human perspective turned out to be one of the strongest moves in the game. By the end of the match, AlphaGo defeated Lee Sedol. For the second time, experts were forced to rethink what machines could do. And once again, the goalposts moved. But what happened next was even more surprising. Because beating humans at games is one thing. Understanding human language is something completely different.
For decades, language seemed impossible for machines. Human conversation isn't just words, it's emotion, humor, sarcasm, context. The same sentence can mean completely different things depending on how it's spoken. Many researchers believed computers would struggle with language for a very long time. Machines could calculate, machines could follow instructions. But understanding people, that was another challenge entirely. Then something changed. Advances in artificial intelligence began producing systems that could recognize patterns in language. At first, the results were limited, but year after year, the technology improved. And eventually, the impossible started looking normal. Suddenly, AI could answer questions, summarize books, explain difficult topics, generate ideas, write articles, and hold conversations that felt surprisingly natural. Millions of people began interacting with AI every day. Students used it for learning. Professionals used it for work. Creators used it for brainstorming. A prediction that once sounded ridiculous had quietly become part of everyday life. Machines weren't just calculating anymore. They were communicating. But there was still one thing many people believed would always belong to humans: creativity. And that belief was about to face its biggest challenge yet. For years, creativity was considered uniquely human. Machines could follow instructions, but they couldn't imagine. They couldn't create. Or at least that's what people thought. When researchers suggested that AI might one day generate artwork, many people dismissed the idea immediately. How could software create something original? How could a machine produce something beautiful? The predictions sounded absurd. Then AI image generators arrived, and almost overnight, the debate changed. People typed a few words into a text box. Seconds later, entire worlds appeared. Landscapes, characters, paintings, concept art. The impossible had happened again. At this point, a pattern was becoming impossible to ignore. People said machines would never defeat world champions. They did. People said machines would never master Go. They did. People said machines would never understand language. They did. People said machines would never create art. They did. Again and again, the same story repeated itself. Every time society declared a limit for artificial intelligence, technology pushed beyond it. And the experts who predicted these breakthroughs didn't stop there. Today, they're making even bigger predictions. Predictions about AI agents, scientific discoveries, and technologies that could change the world once again. If you want part 2, where we explore those predictions, comment part 2 below.
And if you're fascinated by the future of AI, subscribe so you don't miss what's coming next.